For over 100 years, every engineer on the planet believed the same thing. A gasoline engine could never turn more than half its fuel into actual power. No matter how much money Toyota spent, no matter how many labs Honda built, no matter what Germany tried, 50% was the wall. It was physics. It was unbreakable. Until three Chinese car companies broke it in the same year using engines that are already sitting in showrooms right now, not in some lab, not in a concept car, in vehicles regular people are driving to work in Shanghai and Hangzhou today. One of those engines was independently tested by Guinness World Records, not by the company that built it, not by Chinese state media, by the same organization that verifies the world's tallest man and the fastest 100-meter dash. And what they confirmed should terrify every engine plant in Detroit, Munich, and Tokyo. Before we get into exactly what China built and why it changes the next decade of the car industry, hit that subscribe button right now. This channel breaks down the technology stories the mainstream car media is either too slow to cover or too scared to cover honestly. We go straight to the engineering, straight to the verified numbers, and straight to the parts of the story nobody else is telling you. If you want to actually understand what is happening in the global auto industry before it hits your local dealership, subscribe now, turn on notifications, and let's get into it. Here is the number you need to understand first: 48.41%. That is the thermal efficiency of Geely's new IHEV hybrid engine, unveiled in Hangzhou in April of 2026. Thermal efficiency sounds like a boring spec sheet term, but it is actually the single most important number in the entire history of the combustion engine. It measures how much of the energy locked inside a gallon of gasoline actually turns into motion, into torque, into your car moving forward. The rest gets thrown away as heat radiating out of your exhaust pipe and your radiator, wasted before it ever touches the wheels. For most of automotive history, a normal gasoline engine wasted somewhere between 65 and 75% of its fuel. You were paying for gas you were never actually using. The best hybrid engines in the world, built by Toyota and Nissan, the companies that basically invented modern hybrid technology, topped out around 41 to 42%. Toyota's Dynamic Force engine family held that line for years, and Nissan's e-Power system, which uses the gasoline engine purely as an onboard generator rather than a direct driver of the wheels, sat in that same narrow band. That number barely moved for almost 2 decades. Engineers did not treat it as a target to beat. They treated it as a wall, the same way athletes once treated the 4-minute mile, a limit baked into the basic physics of burning fuel inside a metal cylinder. Geely didn't nudge past that wall. They blew through it by more than 6 full percentage points, and Formula One engines, the most expensive, most obsessive, most over-engineered machines on Earth, machines that cost more than most houses and get rebuilt after every few races, only sit a couple of points higher than that. A mass-produced family sedan that regular people can finance at a dealership is now operating in the same performance neighborhood as a multi-million-dollar racing engine. So how did they actually do it? Geely paired the engine with something they call AI Cloud Power, a real-time control system built on their full domain AI platform. Instead of a fixed set of rules deciding when to run on the gas engine versus the electric motor, the car is constantly pulling in outside data, altitude, humidity, outside temperature, road conditions, and recalculating the optimal split between gasoline and electricity multiple times per second. Geely claims that alone accounts for more than a 10% efficiency gain over a conventional hybrid setup. The result is a car that runs on pure electric power roughly 80% of the time, using the gasoline engine almost like a backup generator rather than the primary source of power, without ever needing to be plugged into a charger. When Geely tested the production version of this system in a real-world highway loop around Hainan Island, the car returned 2.22 liters per 100 kilometers. To put that in terms Americans understand, that is roughly 106 miles per gallon in a real gasoline-powered sedan you could buy today. Guinness World Records verified that figure, and it beat the previous record, which belonged to a Toyota Prius, by more than 12%. Under the hood, the engine itself runs a compression ratio of 15.5 to 1, far higher than a typical gasoline engine.
combined with Miller cycle valve timing and an ultra-high pressure fuel injection system, all working together to squeeze more usable energy out of every drop of fuel before it ever gets converted into heat. The battery pairing it with the electric motor is just as deliberately engineered. Geely built the pack around what it calls its Shield battery safety standard, using flat plate liquid cooling that Geely says moves heat away from the cells more than 3 times faster than a typical air-cooled pack, wrapped in an IP68 rating, meaning it is rated for dust and water resistance, roughly 48 times stricter than the national safety standard in China. The battery management system also deliberately keeps the pack cycling only between 30 and 80% charge, avoiding the deep discharges and overcharging that wear batteries down over time. To prove long-term durability, Geely ran what it calls the Hybrid System Reliability Ironman 7 Endurance Test, a brutal, multi-stage torture test supervised by an independent Chinese automotive research institute before the system was cleared for mass production. But the most fascinating part of this story is not the headline number, it is the microscopic engineering war Geely fought to get those last fractions of a percentage point, because this is the part almost nobody is telling you. Inside a piston and cylinder assembly at just 2,000 revolutions per minute, friction between metal components occurs up to 960,000 times every single hour. Nearly 1 million tiny collisions of metal on metal every hour in every engine, quietly stealing power and turning it into wasted heat. Geely's engineers ran more than 200 rounds of component testing and experimented with over 70 different lubricant and coating formulas just to attack this one problem. They eventually landed on 11 separate friction reduction technologies working together, including precision grinding processes and diamond-like carbon coatings applied to internal components, paired with a new low-viscosity engine oil. Together, those 11 technologies cut friction losses inside the engine by 16.3%. On its own, that single improvement, invisible to any driver, added roughly 0.4 of a percentage point to the total thermal efficiency number. That is how tight this competition has become. Companies are now fighting over fractions of a percent hidden inside the microscopic surface of a piston wall, and Geely was not alone for long. Within weeks, Chery, one of China's oldest and most export-focused automakers, answered with an engine called the Kunpeng Tianqing, hitting a claimed peak thermal efficiency of 48.57%, edging out Geely for the highest publicly recorded figure for a mass-produced combustion engine anywhere in the world. Chery achieved this using a 26:1 expansion ratio compared to the 12:1 or 14:1 ratio found in most mainstream engines, combined with a proprietary mechanical system they call dual-curve triple linkage, along with an exhaust gas recirculation rate of 35% and a thermal barrier coating applied inside the combustion chamber itself. This was not a lucky lab result. Chery poured more than 3 billion yuan into this single-engine program, involving over 500 engineers. The company has filed more than 200 patents connected to the technology, over 60% of them full invention patents rather than minor design patents. To validate the design, Chery's engineers ran more than 1,000 separate bench tests, totaling over 50,000 hours of continuous testing before they were confident enough to put the engine into production. Chery's engine roots actually go back to 1999, when the company built China's first fully independently developed engine inside what has been described as a rundown factory with zero foreign technology transfer and zero joint venture assistance. 27 years later, that same engineering lineage just set a world record. Then, a third Chinese automaker joined the fight, and this one comes with a twist most viewers will not see coming. Changan Automobile unveiled its Blue-Core hybrid system in March of 2026, built around what it calls the world's first 500-bar ultra-high-pressure direct injection hybrid engine. 500 bar of fuel pressure is roughly 42% higher than the industry average, allowing incredibly precise, incredibly fine atomized fuel delivery directly into the combustion chamber. The system reached 44.28% thermal efficiency, slightly behind Geely and Chery, but Changan claims it can push everyday SUVs into the 3-liter per 100-kilometer range in city driving and sedans into the 2-liter range. Changan says the program took 6 years, involved more than 1,000 engineers, cost over 2 billion yuan, and mastered 163 separate technologies along the way. Here is the twist.
The actual 500-bar direct injection hardware inside this supposedly all-Chinese breakthrough engine was developed in partnership with Finia, an American fuel systems company operating under the globally recognized Delphi brand. In other words, one of China's flagship engine breakthroughs is quietly running on components engineered by an American supplier. That is not a detail you will find in most of the videos covering this story. Changan also put the whole system through what might be the most brutal reliability program of the three companies. Before releasing Blue Core to the public, Changan logged more than 2 million kilometers of full vehicle reliability testing, ran over 70 specialized road tests across different terrain and climate conditions, completed 350 hours of uninterrupted bench testing, and pushed the system through more than 1,000 hours of extreme condition testing, covering everything from desert heat to Arctic cold. Changan even engineered the cabin experience around the hybrid system, adding piston stop control and what it describes as reverse sound wave cancellation technology specifically to keep the gasoline engine quiet enough that passengers cannot easily tell when it switches on. None of that shows up on a spec sheet, but it is exactly the kind of detail that determines whether a hybrid system actually feels premium in the real world or just looks good on paper. Now, here's the question almost nobody is asking. Why is China, the country that now controls roughly 70% of the entire global electric vehicle battery market, suddenly pouring billions of dollars back into old-fashioned gasoline engines? It sounds backwards. It is not. Inside China, new energy vehicle penetration has already crossed 50% of new car sales, meaning the domestic EV war is basically already won. But globally, the picture looks completely different. Roughly 70% of the entire planet still buys and drives gasoline-powered vehicles, and huge parts of the world, from rural Africa to parts of Southeast Asia to entire regions with unreliable electricity grids, simply cannot support mass electric vehicle adoption yet. Charging infrastructure does not exist. The grid cannot handle it. Chery has actually built an entire corporate strategy around this reality, calling it equal rights for ICE and electric vehicles, arguing openly that customers in gasoline-dependent markets should not be forced to sacrifice modern technology, intelligent driving features, or comfort just because they are not ready for a plug-in car. This is the real strategy hiding underneath the record-breaking headlines. China is not choosing between electric and gasoline. It is trying to dominate both at the exact same time and using its gasoline engine breakthroughs as an export weapon for the roughly 70% of the world that EVs have not conquered yet. Chery has gone even further than just building a more efficient engine. Using an integrated system it calls Mars StarCore Mind, Chery is working to give gasoline-powered cars the same perception, decision-making, and execution intelligence that has, until now, been treated as an exclusive feature of electric vehicles. In plain terms, Chery is trying to make sure a gasoline car never feels like the outdated option next to an EV on a dealership floor, matching it feature for feature on intelligent driving assistance, in-cabin technology, and real-time software updates. That is a direct shot at the entire premise that gasoline cars are yesterday's technology, and it is coming from one of the very companies that also builds electric vehicles for a living. And the export numbers are already staggering. Chery has led all of China's auto exports for 22 consecutive years in a row, has surpassed 16.3 million users worldwide, and now produces more than 3 million engines annually. Its expansion into the Middle East, especially the United Arab Emirates and Saudi Arabia, is being described internally as a dual-core driver of its shift from, quote, China's export champion to a self-described global AI technology company. Changan, meanwhile, just unveiled an updated global expansion plan called Vast Ocean Plan 2.0, targeting 1.5 million overseas vehicle sales annually by 2030, with a stretch goal of 1.8 million. Changan already sold 637,000 vehicles overseas last year alone, up nearly 19% year over year, and now operates in 118 countries through more than 1,100 sales outlets, backed by 22 overseas manufacturing plants. These are not experimental side projects. This is a coordinated, multi-company, multi-billion-dollar push to make Chinese engineering the default choice for a huge share of the planet's next generation of gasoline and hybrid vehicles. There is also a quieter European angle to this story that almost nobody outside the industry pays attention to. Geely does not just own its own Chinese brands, it also owns Volvo and holds a major stake in Polestar. And the same CMA compact car platform underneath the record-setting IHEV system is the exact same architecture that underpins current Volvo XC40 and Polestar 2 models. That means some version of this efficiency technology, or at least the engineering lessons learned from building it, has a realistic path into European badged vehicles over the next few years, filtering into the market through brands that most Western buyers do not even think of as Chinese-owned. Which brings us to the part of the story that almost every other video covering this topic leaves out completely. If these engines are really this good, why can't you walk into an American dealership and buy one? The answer has nothing to do with engineering and everything to do with policy. In January of 2025, the United States Commerce Department finalized a rule banning the import or sale of connected vehicles containing Chinese or Russian hardware or software, citing the risk that internet, connected components, cameras, microphones, and GPS systems could allow a foreign adversary to gather sensitive data on American drivers or even remotely manipulate vehicles on American roads. Around the same time, the United States raised tariffs on Chinese electric vehicles from 27.5% all the way up to 100%. And critically, the new connected vehicle rule was specifically written to close a loophole automakers might have used building factories in Mexico or other third countries specifically to dodge the tariff wall and sneak Chinese engineering into the American market anyway. That loophole is now closed. It means that even as Geely, Chery, and Changan set legitimate, independently verified world records in engine efficiency, American consumers are legally locked out of buying any of it, not because the technology fails to meet safety or performance standards, but because of a deliberate national security decision made in Washington. This is genuinely one of the strangest moments in modern automotive history. The most efficient gasoline engines ever built for mass production exist right now, today, and the world's largest car market has made it effectively illegal to sell them there. China has not stayed quiet about any of this. In direct response to escalating American restrictions on chips and connected vehicle technology, China has restricted exports to the United States of critical minerals, including gallium, germanium, and antimony, materials that are essential for manufacturing semiconductors, batteries, and other advanced components used across the auto industry. China currently accounts for the overwhelming majority of global refined gallium and germanium production, giving it enormous leverage in this standoff. Chinese automaker BYD has also fought back through the American legal system directly, filing a lawsuit against an American manufacturing advocacy group over its public statements, a case that was ultimately rejected by a United States District Court, then by the Court of Appeals, and finally by the United States Supreme Court. Both sides are treating this as far more than a simple trade dispute. It is being fought with tariffs, export bans, courtroom battles, and now, quite literally, engine efficiency records. Now, before you assume every number in this story is bulletproof, it is worth being honest about the parts that remain unverified. Geely has been notably quiet about exactly which specific trim levels and markets will receive the record-setting IHEV system first. and has not published a firm global rollout timeline, which some industry analysts have flagged as unusual given how loudly the record itself was publicized. The verification processes themselves, while independently run by Guinness World Records, are still built around controlled test conditions, a highway loop in Hainan, a specific test vehicle, specific weather, and real-world daily driving across different climates. Traffic patterns and driving habits will likely produce different results than the record-setting run. None of that erases what these companies have accomplished, but it is worth remembering that a peak lab result and an average result experienced by millions of daily drivers are not automatically the same number. The same caution applies to Chery and Changan. A peak thermal efficiency figure describes the single best operating point an engine can hit under ideal conditions, not necessarily the average efficiency a driver experiences stuck in traffic, running the air conditioning, or driving in freezing temperatures. Independent, long-term ownership data from real customers collected over years rather than a single test loop is really the only way to know for certain whether these numbers hold up outside a controlled demonstration. That data does not exist yet, simply because these engines have not been on the road long enough to generate it. Here is what all of this actually means. For the first time in decades, the country leading the world in electric vehicle technology is also the country breaking world records in old-fashioned gasoline engine efficiency at the exact same time, using the exact same corporate playbook of state-backed investment, aggressive patent filing, and relentless export expansion that already made it the dominant force in EVs. Whether or not any of these three engines ever legally reaches an American driveway, the message to the rest of the global car industry is impossible to ignore. The combustion engine was supposed to be dying. Instead, it just got smarter, more efficient, and more Chinese than anyone in Detroit, Munich, or Tokyo was prepared for. Think about how fast this actually happened. Three separate companies, inside the same handful of months, each independently pushed past a ceiling that the entire global industry had treated as fixed for 20 years. Not one lucky breakthrough from one lab, but three competing corporate engineering teams arriving at almost the same result through three completely different technical paths. One through artificial intelligence and motor control, one through mechanical linkage and expansion ratio, and one through raw fuel injection pressure. That kind of simultaneous competitive leap is usually the signal that an entire industry has quietly shifted its center of gravity. And in this case, the center of gravity for gasoline engine innovation has clearly moved to China, whether the rest of the world is ready to admit it or not. If this video actually taught you something the other channels covering this story left out, do me a favor and hit that like button and subscribe if you have not already, because we are going to keep digging into exactly how China's auto industry is quietly rewriting the rules of this entire market, one engine, one battery, and one export deal at a time. Thanks for watching, and I will see you in the next one.